So today we're going to be taking you through a little bit of anatomy and physiology of the sense of equilibrium. The sense of equilibrium is controlled by the vestibular system in the inner ear, which consists of the semicircular canals and the vestibule, which is right here, but it's not labeled. Aesthetic equilibrium is our body's sense of orientation with the Earth's gravitational, and this part of equilibrium is controlled by the vestibule. Inside the vestibule are two sacs, the utricle and the saccule, and inside of these sacs are patches of sensory cells called maculae. There are hair-like projections that come from these maculae into a gelatinous substance above it called the otolithic membrane. Gravity acts on the otolithic membrane, which is free to move, and when it moves, it exerts a force on these hair-like projections, which causes nerve impulses to be sent to the brain, giving us a sense of our relationship with Earth's gravitational field. However, gravity is not the only force that can act on the otolithic membrane. Acceleration forces will also act on it. So if you're in a car that's accelerating quickly or in a jet that's taking off, you will feel a sensation of movement caused by the movement of the otolithic membrane across the hairs of the sense of dynamic equilibrium is controlled by the three semicircular canals located in the inner ear. This is responsible for sensing the rotational movement of the head. So each one of these semicircular canals is on its own axis of movement, the X, Y, and Z axis. This diagram isn't in quite the right orientation to show that properly, but that's the way they are. Now, no matter how you move your head, because of the orientation of these three canals, the movement will be sensed by one or more of them. And how this works is inside of the canals there's this fluid, and there are these patches of hair called the crista ampullaris. Now, when you move your head, the canals obviously move with your head because they're attached to your head, but the fluid inside of the canals doesn't move at the same rate because its energy for movement has to be imparted to it through friction with the walls of the canal. So this relative movement between the walls of the canal and the fluid inside of the canal stimulates the crista ampullaris, sending nerve impulses to the brain, which tells our body about the rotational movement of our head.